there are a couple ways to solve this question. Some of them are more time consuming than others. I am going to show you the shortest way. At least I think it's the shortest way. And because I think it really gets to one of our strategies and it really uses it in the way it's intended. So you've probably heard me use the get back to basics strategy a lot in my videos. And the idea is basically this. If you look at a weird question, it's testing something that you are familiar with. You might not recognize it instantly, but this stuff on the SAT is stuff you've learned in school. So you want to get back to the basic version of what this is, so that way you can understand and use the stuff you learned in school more easily. And so we've seen already for this question, this grouping of questions, that this is really a linear relationship. And there's a couple of clues to that, right? So first and foremost, they tell us that it's a growth constant, right? The growth is constant. And that phrasing is linear. It is something we see in lots of SAT questions. It is a clue that we're dealing with a line. More important, the equation that they tell us is, by the growth factor, is a linear equation, right? So the age is equal to the diameter by the growth constant. Because the growth constant sounds more like a slope, we might want to rewrite this just a little backwards so it matches up with our y equals mx plus b. So we don't have a b in this example, just because they didn't give us one, and because I guess a tree is going to start off with a zero stem. I guess I don't know. So why is that helpful? Why does that allow me to make a shortcut? Because when they tell us to compare the white birch and the pin oak, it doesn't really matter what their current diameter is. Because no matter what, if 10 years pass, since the growth is constant, the same amount of growth is going to happen. Basically, let me phrase it another way. If the trees are brand new and 10 years go by, they're going to change, their diameter is going to change in the same way that if they were 100 years old and 10 years went by. Because growth is not dependent upon age. It is constant, so no matter how old the tree is, if in the same amount of time, it's going to grow the same. So from 0 to 10, it's going to grow the same as if from 10 to 20, from 20 to 30, from 30 to 40, all the same. So why does that matter? Well, now we can take this equation, and we know we want the white birch, so that's this guy, and the pin oak, which is this. So we know that if 10 years pass, and this is the white birch, 5 is the growth constant, then the diameter is just going to be 2, right? 10 divided by 5. And then if I have the pin oak, the 10 years, it's going to grow at a different rate. It's going to grow at whatever this 3 is, and we have to maybe use the calculator for that. 10 divided by 3 is 3.3. There, we'll just leave it at that. 3.3. It doesn't matter how big the trees are right now. It doesn't matter how old they are right now. We could find those things, but we do not need to, because 10 years is going to look the same to that pin oak, whether it's 3 years old, 30 years old, or 300 years old. 10 years is 10 years. The growth is constant. And so now the difference just between these two, we can kind of see is the 1.3, which is the answer. Now, the reason that this is a weird way to do it is that just from an SAT standpoint, it's very, very rare that we are given information that we don't use. So in this case, we were told that the trees are a foot wide, thick, whatever, and we were told the conversion because the equation specifically tells us that this equation is in inches. So we have to think in terms of inches. But we don't end up using that. We don't need it because we understand that lines are not dependent upon where they're starting from, right? The starting point isn't going to matter because the slope is really what we're being asked about here. If that's weird to you, then yeah, you can just use the current diameter to find the current age and then add 10 and then do the subtraction at the end, but you're going to get the same answer. So just keep in mind the get back to basics strategy. And if you ever feel a little lost in a question, try to ask yourself, like, what is this really asking about? What is this similar to? The odds are good it's lines, because lines come up on a lot of questions, but it could be a lot of different things. And it helps center you and get you thinking along the right path in your brain so you can use the right information and the right equations to help you solve. And occasionally, yes, it lets you take a shortcut.